Hi everyone, it's Mrs. Sommer here to talk about the introduction to the Unit 6 and dimensional analysis. So the goals of this lesson is to view an overview of the unit, set up and calculate conversions, and practice dimensional analysis set up using nonsense conversions. Hi everyone, so where are we going with Unit 6? Stoichiometry is the relationship between the amount of substances in a chemical reaction. We're going to be able to calculate how much a reactant is needed or how much product will be produced in a reaction. But how to get there is baby steps. There are a ton of new units that we're going to learn this unit, like mathematical units that we're going to learn. And so the math is the same, the setup is the same, but how to get there can get confusing. So make sure you are writing your notes and taking those, showing all of your steps and work. So to recommendations for this unit, take your time. Use your resources, practice, do the learning assignments. And remember, this was also made from last quarter. And remember, if you want to get a 100 on the learning experience for this unit, you need to complete the should do's, which are your L assignments this quarter. And then ask for help. I'm always here. And then don't give up. It'll click. It's just a pattern, but it will click eventually. So where are we going? So 601, we're going to learn how to set it up. We're going 602, what's a mole? What's Avogadro's number? We're going to learn some new units in this lesson. Mole to mole ratios. Then molar mass, moles to grams, grams to moles, moles to particles, particles to moles, volume, moles to volume, and back again. And then we're going to get into stoichiometry, which is where we're converting between different parts of a chemical equation. So we may be given hydrogen and we need to calculate the number of oxygen in a chemical formula. All of the previous lessons we're converting between the same substance. Here we're becoming between two different substances. So what is dimensional analysis? It's a problem-solving method that uses the fact that any number can be multiplied by 1 without changing its value. So for example, 1 inch is equal to 2.54 centimeters. We can also write it as 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. These here are conversion factors. So setting up the problems, we're going to use railroad tracks. You might see me doing them, setting up a little bit different as we're going through our live sessions. I use parentheses instead of the straight line, vertical lines in between. It's the exact same thing. And how you do that is that what you are given in the problem goes here. This bottom is not used. Then we use our conversion factor. If the given is in like grams down here goes in the bottom with our conversion factor. And where you're going units. So this is what we want to find. So here's an example. How many inches are in 653 centimeters? So in this example, how many inches are in 653 centimeters? 653 centimeters is what I was given. My conversion factor, my inch is what I want, so it goes on top over on this second part. My centimeters of my conversion factor goes on the bottom because what I want to do is I want my units to cancel. And when I do that, I get 653, we do multiply across, so 653 times 1 divided by 2.54 equals 257.1 inch. So in 653 centimeters, there are 257.1 inches. So you try. Given 329.45 inches, how many centimeters are there? So in this problem, you're given the number of inches. So on the bottom of my conversion factor over on the railroad track, inches is on the bottom, 2.54 centimeters is on top. And that way I can cancel my inches unit. And I'm left with centimeters. And then 629.45 times 254, or 2.54, sorry, divided by 1 equals 1,598.8 centimeters.